Welcome to qnawire.
Okay, I think the best way to answer this question is to realize what kind of reaction is this. If the whole of our reaction is this is a substitution reaction. Now, we know that substitution reactions can be SN1 or they can be SN2, right? Those are the two types of reactions you learned about in an introductory organic chemistry class. What does this 1 and this 2 mean? Well, what the 1 represents is that at the rate determining step, so RDS, it is unimolecular. Whereas the 2 means at RDS, the reaction is bimolecular. What does rate determining step means? It means the slowest step. What does unimolecular mean? It means there's one molecule involved. Whereas bimolecular, bimolecular means two molecules involved. So let's give an example of a unimolecular reaction. Well, there's a really good one here, and it is this. Chlorine leaving is a unimolecular step or reaction. An alternative to this might be if we've got bromine here and we've got OH minus coming in. This is bimolecular. And this is unimolecular. So for SN1 reactions, this is just a matter of fact, this is true. The rate determining step is unimolecular, and it involves typically a leaving group leaving a secondary or tertiary alkane. And that's exactly what step 1 is. So this is the slow step of an SN1 reaction. What does it mean to be a slow step? It means that if we look at a reaction coordinate diagram, so let's just call this E, and we've got, our reactants and maybe our products are down here, and let's say this was maybe let's do a 3-step reaction. Intermediate, another step, another intermediate, another step. Okay, the slow step is the one for which the delta E is the highest between the either starting products or intermediates and the final products, right? So in the case of an SN1 reaction, this leaving from a tertiary halide or from a tertiary carbon or alkane is the slow step, which is to say that its delta E is the most energy intensive. Its activation barrier is the highest. Free energy activation. Actually, this should be delta G. I didn't realize that they said free energy. But yeah, the same is true. This is the leaving group leaving. This is step 1. That's the highest. Then there's step 2 and step 3. And you just know this without even building this chart because it's an SN1 reaction, and they tell us that the slow step is unimolecular. None of these other steps in this reaction are unimolecular. There's water coming in, there's things coming in to deprotonate, et cetera, et cetera. So the answer is step 1.